This is a recording on the standard normal distribution. So the first thing we need to understand is what is a normal distribution. Okay, so earlier in the course we described a normal distribution as bell-shaped and symmetric. Okay, this distribution actually has a probability density function, which is really complicated. Okay, the probability density function is given as f of x is equal to e to the -1/2 times x minus mu over sigma squared over sigma times the square root of 2 pi. Yep, that's exactly what it looks like. Do you need to memorize this? Absolutely not. But if you have a bell-shaped symmetric distribution where its mean is mu and its standard deviation is sigma, this will produce the probability distribution function, or the probability density function. All right, so that's all technical, fine and dandy. If the mean is equal to 0 and the standard deviation is equal to 1 of this bell-shaped curve, we call this the standard normal distribution. So that's what's called the standard normal distribution. Okay, so mean is 0, standard deviation is 1. All right, so we're going to work through an example on this of finding a probability. And we're going to use the calculator to do that because we're never going to use this formula by hand. Okay, so let's say we have a population. And if I take a measurement on that population, that measurement is distributed by a standard normal distribution, which means its probability density function is the symmetric bell shape with a mean of 0 and a standard deviation of 1. Now, the question that I have is that if I pick a person or an item from this population at random and I measure it, what is the probability that I will choose an item whose measurement is between -1 and 1. Alright, so this means that I want to know what is the probability that, like, if this is the mean at 0, I am between -1 and 1, which should be the area of this portion of the curve. And the calculator actually does this really simply by using what's called a normal CDF distribution. The C here stands for cumulative density function, but we will get to that right now. Okay, so here's my TI-84 calculator, and I want the probability given the standard normal distribution that I'm going to pick something from the population that has a measurement between -1 and 1. So I hit second, and then I hit vars, and the second item down there, number 2, is the normal CDF. That's the one I want. And it says, what is my lower bound? My lower bound is -1. My upper bound is 1. And there I have the mean of 0 and the standard deviation of 1. So I paste that. and then I hit enter, and it tells me that the probability of choosing a member in that population that measures between -1 and 1, and I ended up with 68.2%. Okay, so at the end of the day there, that gets me something that's completely expected to me. Okay? Because why is that expected? Because earlier in class, we've talked about the empirical rule, and if I'm within one standard deviation of the norm, I should expect to have approximately 68% of the population. So this is a completely expected result. So how do I find a range, the probability of getting a range of values under the standard normal? I use the normal CDF with a mean of 0 and a standard deviation of 1.